Good morning, everyone. Welcome to this video lecture on Control System Engineering, module number 3, that is time response analysis. So, today in this video lecture, we will solve some examples of problems related to steady state error, how to find the steady state errors with respect to the input signals which we have applied to the control system. Okay, so if I consider a system and if I apply a signal, for example, it can be a unit step signal, it can be a ramp signal, okay, or it can be a parabolic signal. So based on these three inputs, you need to determine the steady state error. Okay, so in our previous lecture, so what we have studied is we have derived the small equations related to all the three constants, that is Kp, Kv and Ka. Okay, so today, after studying the whole concept of yesterday's class, so here we will go and see how to solve the few problems related to these particular three equations. Okay, so if you look at this figure here, okay, this is the table number 7.8.1. so in this particular table 7.8.1, here if you know okay, which type of system it is, whether it is type 0 or it is type 1 or it is type 2, based on the type of system, they will ask you sometimes to find the value of Kp, Kv and Ka for the given three input sequences or three different signals, or the question will be like find the steady state error, okay, for the given transfer function, that is g of s will be given, and you need to calculate the error coefficients. In the sense, you need to find the value of Kp, Kv and Ka, and sometimes they will ask you, you need to find the error coefficients for this particular applied signal. Okay, and the another thing which we can solve here is nothing but based on the yesterday's concept, we'll take some example and we'll try to find the value of Kp, Kv and Ka. So in this example number 7.14, the question asked here is determine the value of Kp, value of Kv and the value of Ka, okay, for a given system equation. Okay, so the one transfer function will be given in the question. Okay, so based on the given transfer function or the given the value of g of s, you need to find the value of Kp, Kv and Ka. So this is just the beginning of the problem. So they are asking only to find the value of Kp, Kv and Ka for this particular equation. Okay, and now in this equation we have not mentioned here it is a which type of system in the question, but if you look at this equation, okay, so in this equation they have given here as h of s is equal to 1. So this particular h of s is equal to 1 represents it's a unity feedback system. Okay, it is unity feedback system, so that is the reason they have given h of s is equal to 1. So based on the given system function or the given equation, you need to analyze the input parameters which they have given in the question. Okay, so now let us find the value of Kp, Kv and Ka for a given system with the g of s, that is 100 divided by s multiplied by s plus 0.5 multiplied by 4 minus s multiplied by s plus 1000, okay, comma h of s is equal to 1. The another thing what we can do here is based on the given system equation, even you can determine okay, which type of system it is, that is whether it is a type 0 system, type 1 system, okay, or whether it is a type 2 system. So based on that particular type, even you can go for finding the solutions for Kp, Kv and Ka. So let us go for finding the value of Kp, Kv and Ka. So considering this system equation, that is g of s into h of s is equal to this equation. Okay, now if you look at this particular equation here, the value 100 divided by we have written in this particular format. Okay, if you look at this format, the name of this format here is nothing but it is a standard time constant. Standard time constant. You need to define, or you need to bring the original signal or original sequence which is given here into this time standard format. The time standard format is given by the equation. It is K, capital K, multiplied by, we have seen in the yesterday's video lecture, it is given by K into the bracket. It should be always in the form of 1 plus. So it is 1 plus TAS, then it will be 1 plus, okay, TBS, okay, plus so on, okay, then divided by, okay, based on the values, it can be your, again it will be in terms of 1 plus TA, okay, multiplied by S, then multiplied by 1 plus TB into S plus so on, okay. This is the standard formula for the time constant, okay. Now one observation what we need to do here is, do we have any S term here? Okay, so if you just compare the given equation with this particular formula, or given with this particular number equation, okay, so in this equation you can see here it is S, okay, you can see a small S term which is written here, okay, and the value of S to the power, it is given by J, okay, it is J, and here the J is nothing but your order, okay. Sometimes it can be poles also, it will give sometimes even the type of system, in the sense, if you don't have here S, it means it is a type 0, okay, and if you have S, only S, then S to the power of 1, right, it means type 1. If it is S square, it means it is type 2 system, okay, it is type 2 system. Now based on this particular given equation, let us find the let us convert this G of S into this particular standard. Your standard function should be always, I repeat, it's your standard function which is given here, it should be always in this format, that is it should be 1 plus, okay, it should be 1 plus. Now if I simply compare the given function G of S with the standard function, okay, here we don't have 1 plus TA of S in the numerator, it is only 100. It means the value of K here is equal to 100, okay, the value of K is equal to 100. Now then after going for the numerator, go for the denominator. Now in the denominator you can see it is S multiplied by S plus 0.5, okay, it is S multiplied by S plus 0.5, 4 minus S, okay, S plus 1000. But now this particular denominator is not in the standard format, or it is not in 1 plus S, okay. So therefore you need to always convert, or you need to always bring the denominator which is in the format of S plus, any value which is in the format of S plus, it should be brought into 1 plus T format, okay. So how to do that is, if you look at this particular S plus 0.5, you need to divide, okay, you need to divide this whole bracket into 0.5, okay, so that it should be 1. So if I divide this S plus 0.5 divided by 0.5, then I will get 1 plus 1 divided by 0.5, right. So here you can see here, so I can take 0.5 as a common, okay. So if you take 0.5 as a common, so this becomes, S will be as it is, 0.5 I have taken outside, so this becomes 0.5, so into 1 is 0.5 plus 0.5 into S divided by 0.5, again I will get the same equation. So therefore S into 0.5 multiplied by 1 plus S divided by 0.05. So now it is in this 1 plus TA format. Similarly do it for 4 minus S. So if I take 4 common, 4 outside the bracket, then it becomes 1 minus S divided by 4, Okay, so I have taken 4 as common. Then similarly, you can take it your 100 as a common. There is a small mistake in the given question. So here it is 1000 here, but they have taken it as 100. No issues if it is 1000 or if it is 100. So whatever the value you have, that is in with respect to s plus value, you just take it outside this particular bracket. So if I consider with this problem as 100, so if this 100 is taken outside, so it becomes 1 plus s divided by 100. Okay, so now this whole equation is in the format which is shown here, that is called as time constant format or standard time constant format. Okay, now you multiply the variables here, that is nothing but 0.5, okay, multiplied by 4 multiplied by 100 multiplied by 100. Okay, so if you do this value calculation, so you will end up with the formula. So that is 0.5 into 4, okay, into 100. So 0.5 into 4 into 100 gives us 200, gives us 200. Now instead of 100, if you take, okay, so instead of 100, for example, if you take something like value which is equal to 1000, if you even if you take it as 1000 also, no issues. So if I take it 1000 or if I make it 1000 here, okay, so it becomes 0.5, okay, into 4 into 1000 into 1000, that completely becomes 2000. Okay, it becomes 2000. If I simply add 10 here, okay, so this value will become 2000, it becomes 2000. Now what you should do, that is 100 divided by 2000. Okay, 100 divided by 2000. So if you do 100 divided by 2000, so the value which we obtain here is 100 divided by 2000 is equal to 0.05. Okay, so it depends on the number which you have taken. Now suppose if I do with the value of 100, that is 0.5 into 4 into 100, so it was 200, right? So if I consider if the value is 200, okay, then what you should do is you should simply make it calculation that is numerator was 100, right? 100 divided by 200, so you will get 0.5. Okay, so you will get 0.5, you can see here. Okay, now there is a small mistake, so they have taken as considering it into the 100 value, so they have done the calculation. Okay, so now what answer we get here is 0.5. How we got the 0.5 here, that is 0.5 into 4 into 100, it gives us the number here is equal to 200. So it is 0.5 into 4 into 100 is equal to 0.5 into 4 is equal to 200. Okay, is equal to 200 calculation. So in this way you need to go for finding the values of this numerator divided by the denominator. So based on these particular values, okay, so we end up with this value, these numbers. Okay, so similarly, okay, similarly you can go for finding the other values. If there is any number associated here, simply you can find this value. Okay, then after doing this, after finding the g of s into h of s into its standard formula or standard number, okay, just rewrite the equations. Okay, you can rewrite. So how to rewrite the equation here is, now it was 0.5 divided by s will be as it is, so 1 plus the number 1 divided by 0.5. Okay, so 1 divided by 0.5, okay, is equal to how much? It is 2, right? So therefore this s will be as it is, 1 plus 1 divided by 0.5, you will get 2. Similarly 1 minus 1 by 4 is 0.25 into s, right? then 1 plus 1 divided by 100 is 0.0 s. So now this value, this particular value is your standard equation. Now if you carefully observe this equation, simplified equation with the standard value, it is in the format of 1 plus t. Okay, both either it is in the numerator or it can be in the denominator. Okay, now once you obtained this equation, this is the must and should. For any given equation, you should convert it into the standard format. Once you obtain this particular equation, then you need to find the value of Ka, Kp and Kv. So how to find the value of Ka, Kv and Kp is equal to, you can just see here that Kp is the formula where limit s tends to 0, simply you write g of s into h of s. So limit s tends to 0, you write whole g of s into h of s, here the formula. Okay, now apply the limits. Now if you apply the limits, s tends to 0 here. Okay, so this s is 0, in the sense anything divided by 0 makes my infinity. So in this way I obtain the value of Kp, which is nothing but your position constant. Similarly, go for finding the value of Kv. How do I find the value of Kp? Kv is nothing but limit s tends to 0, s in, simply add the s to the system function, s into g of s into h of s. Now if you apply, okay, the limits to this particular value here, then you will find it is 0.5. But actually it is nothing but your k value. How this is k value? For this particular equation, you can remember the value of that table, what we have table which we have considered in yesterday's class, that is this particular table. I'll just show you the table. Yes, this table you can consider. Okay, so based on this table here, based on this table here, they have asked us to find the value of Kp, Kv and Ka. So which type of system is more important? Okay, so which according to the problem which we have considered here is in the numerator, okay, sorry, in the denominator we have s. So it is only s. If it is only s, it means it is your type 1 system. Okay, if it is type 1 system, okay, if it is type 1 system, you should consider the second row. Okay, second row. For second row, the value of Kp will be always infinity, right? So it is always infinity. So therefore in the given problem here also, the value of Kp is infinity. Similarly, go for finding the value of Kv. So for the value of Kv is equal to s tends to infinity, s tends to 0, s into g of s, write the whole equation. Here how you got the 0.5 with respect to this table. Okay, here in table the value of Kv for a type 1 system is equal to k, is equal to k. So what is the value of k here we obtained from the equation is nothing but it is 0.5. I have told the numerator value which is given 100, after simplification we got it is 0.5. It means the value of k is equal to 0.5. That is the reason we got it as 0.5. Now go for finding the value of Ka. Is the formula here is limit s tends to 0, s square g of s into h of s. Always remember, if you don't have any value here, if it is only g of s into h of s, it is nothing but your Kp. If you write s into g of s into h of s, it becomes your Kv. If you write in terms of s square, it means it is g of s into h of s. This is one observation. Okay, now simply you enter the values here, that is s square into 0.5. If the value is Ka, then with respect to the table here, for type 1 system the value of Ka is 0. Okay, so therefore here we can conclude that the value of Ka is equal to 0 for this particular input applied. So this is how we try to find the value of Kp, Kv and Ka. So it is necessary for everyone to know the values of the standard values of error coefficients, either for type 0 system, type 1 system, or it can be type 2 system. Okay, so based on that type you can simplify your answer. And how to identify for any given system equation, whether it belongs to type 0, type 1 or type 2, is nothing but it completely depends on this particular value of S. If you don't find any S, if you find only these brackets, it means it is type 0. If you find only S with respect to this brackets, it is type 1. If you find it is S square, then it belongs to type 2. So during that conditions, you should follow this particular table so that we can easily find the error coefficients, or you can easily determine the error coefficient for any type of the system based on the given transfer function in the given question. So with this, I conclude this problem here. Okay, try to solve more problems and make sure that you find the solution for any given problem.